Hello students, and welcome to another how-to video. Today we're going to be discussing single replacement reactions. We have two problems that we're going to work through. Alright, so let's just dive in. So in this first problem we have aluminum and we have iron to nitride, aluminum nitride, and iron that's alone, it's just pure iron. So when we look at this, aluminum is going to replace iron and form a bond with nitrogen, and iron is going to be left out here, okay? So in order to balance this equation, let's just start kind of with our obscure elements, which iron is kind of our obscure element here. So let's do, there's 3 irons here and there's only 1 iron on this side, so let's add 3. So we have 3 irons and 3 irons. Okay, let's go to aluminum next. So aluminum, we have 1 and 1. Okay, aluminum's balanced, and then we have N2 and N. So our nitrogens do not balance. So let's balance them. So let's add a 2 to here. So we have 2 nitrogens, but we also have 2 aluminums now. So we have to add another aluminum over here. So if we check this out, we have 2 aluminums, 2 aluminums, 2 nitrogens, 2 nitrogens, and then 3 irons and 3 irons. So this equation now, this reaction now checks out. It balances on both sides. We've now conserved the mass on both sides of the equation. All right, now let's work on this one down here. So potassium and water react to form aqueous potassium hydroxide and hydrogen gas. Okay, and hydrogen is a diatomic molecule. Okay, if you've watched the previous videos, I've discussed that in depth on the other videos. Okay, so we're going to write potassium, and it's a solid at room temperature, plus H2O, and that's a liquid. And it's going to react to form KOH, and this is aqueous. It's going to be dissolved in the solution, right? Aqueous potassium hydroxide. The hydroxide on here, we've talked about this in previous videos. The OH, it's one of those things you're probably going to have to memorize. It's a polyatomic ion, and if you look at the problem, it says hydroxide, hydro oxygen, right? It's a OH group, okay? And it's going to form H2 gas. Remember, hydrogen's diatomic, so it's going to exist in a pair. And as we're solving this problem, we're going to kind of scan over the problem. We're going to see we have 1 potassium on each side. We have 2 hydrogens and 3 hydrogens, so our hydrogens are off, and we have 1 oxygen and 1 oxygen. So the only thing that's really out of balance is the hydrogens. So let's balance the hydrogens. So if we have 3 on this side and we have 2 here, all right, so if this is going to have 3 hydrogens and this has 2 hydrogens, okay, let's add a hydrogen to this KOH, okay, because if we find the one that's single and make it a multiple of 2, we can just work with this over here. So now if we have 2 hydrogens and 2 hydrogens, we now have 4 hydrogens. And all I got to do is add a 2 on this side. So now I have 4 hydrogens. My hydrogens now check out. Now let's go back and look at the ones that were balanced. So now we have 2 oxygens. Oh, our oxygens check out. And if we have 2 potassiums, we need a second potassium over here. So we have 2 potassiums for 2 water molecules for 2 aqueous potassium hydroxides, and 1 molecule of hydrogen gas will be released. Okay, I think that's it for this equation. Thanks for watching.